Again, we're looking at 8.3 nodes. We had a warm up to start. Lots of different ways to solve this guy, right? You should be able to find this guy, right? You should be able to find this guy up here. You should be able to find this, and you can use law of sines. You can use SOHCAHTOA to do this because I'm assuming this is perpendicular, making that 90. You could also use special right triangles, 45, 45, 90, if you know the patterns, x, x, and x root 2. And you have a 30, 60, 90 triangle. So you can use that pattern as well. If you remember 30, 60, 90, x, x root 3, and 2x, because we have a 30, 60, 90 triangle. So you got lots of different ways to solve this, okay? First off, we know this distance, right? This ship is what, 100 feet from the base? And this ship is how far? How far is that? That's 173 point what? 0.2 feet. Well, that goes back to this is x, x, and x root 2 for this guy. So if I take 100 times root 2, I should get 141.4 on one decimal place. Okay. And then this guy is 30, 60, 90. This right here, across from that is x. This would be x root 3. So 100 times root 3, which is 173.2. And then this guy is the difference of the two, which is what, 73.2 feet. So from ship to ship. And then 30, 60, 90, this distance you should get is 200. You're actually finding the distance to the guy. And that's the diagonal. Okay. So again, you can use SOHCAHTOA to answer all those questions. You could use some law of sines to answer their questions. Or if you know your pattern, because it's a 45, 45, 90 or a 30, 60, 90 triangle, you can use your pattern. X, x, and x root 2. You got x, this is x root 3, and this is 2x. Okay, so lots of different ways to answer that question. You got those values correct. You're going to get those values correct. Whether you use SOHCAHTOA, special right triangles, or what have you, awesome. Fantastic. Okay. Well, ladies and gentlemen, we are going to be working on a law of cosines today, and we're going to be dealing with a sassy triangle or a side-side-side triangle. So that's the triangles we're going to be dealing with today. So if we take a look, here is your law of cosines. So as I take a look, here's your law of cosines. The thing I like to look at is the bookends. The guys on the ends are the side and angle that are across from each other. C is across from gamma or big C. Little b is across from big B or beta. And little a is across from big A or alpha. All right. Then everything else is kind of filled in, right? You will not see little c on this side. It's all essentially looks like with Pythagoras, right? A squared plus b squared equals c squared, but then minus 2ab cosine again. B is over here. You will not see a b over here unless you see the big beta. Then it's a squared plus c squared minus 2ac cosine of beta, and so on and so forth. Okay? We know total angle measurement of a triangle is 180, so that doesn't change at all. And we have to use law of cosines when we see a sassy triangle or when we see a side-side-side triangle. Okay? Now, some of you guys are going to like law of cosines and you want to use law of cosines all the way through, and that's fine. Then there's no rules to follow. But some of you guys want to just use law of cosines one time and then jump back to your favorite law of sines. And if that's the case, then we have to be aware that law of sines doesn't find obtuse triangles, right? We talked about yesterday is sometimes when we have the angle side, those can be a real pain in the side angle, right? Because there's an ambiguous case. So we have to be aware of inverse sine doesn't find obtuse angles. So there's some rules that we have to follow, and I'll explain as we go. Okay, so let's go ahead and get rolling here. The first one we have is a sassy triangle. And when I have a sassy triangle, I've got to follow my little law of sine, or law of cosine, excuse me. So law of cosines, the only thing I can solve for right now is A. Okay, so across from A is alpha. They gave me that angle. So I've got B squared plus C squared minus 2BC, and then the cosine of alpha. And plug it in, plug it in. Go ahead and plug in the stuff. In this case, across from beta is little b, so that's little b. So that's 3. Across from gamma is c, so that's c. That's 4. Minus 2 times 3 times 4, and the cosine of alpha, which is 40 degrees. Okay. Now, if you get the 3's and the 4's mixed up, does it matter? It doesn't. If you put 4 squared plus 3 squared, doesn't matter. It's the same. If you put negative 2 times 4 times 3 times the cosine of 40, it doesn't matter. It's the same thing. Okay. Now I can plug all this in my calculator, or I can do it in my head. I can say, hey, what's 3 squared? 9, what's 4 squared? 16, and I add together, it's 25. 9 plus 16. And then 2 times 3 is 6 times 4 is 24. And then the cosine of 40. I can't combine those things. Those are separate. Those are different. So I can just throw that in the calc. I got 25 minus 24 cosine of 40. Always make sure you're in degrees, which I am. You should know that if you're not, just go easily switch it in your mode. And I got, what, 60 or 6.6 approximately? Well, that's a squared, so make sure you square root it. So I'm going to go ahead and square root. Copy and paste that guy. And I get A is about 2.6-ish. Everybody okay with that? Now, this is where you have to decide. Did you like doing law of cosines? Or do you want to jump ship and use law of sines? You want to use law of sines? Well, if you're going to do that, then you have to follow this rule. Okay? When you have a sassy triangle and you want to switch to law of sines, then we got to follow this little rule. You have to find the small angle. If you're going to use law of sines. Okay, so again, if you want to switch for law of sines, but you must find the smallest angle. So if you have a sassy triangle, a side angle side triangle, you can, in the second step, switch to law of sines, but you have to find the smallest angle. Because inverse sine does not find obtuse angles. And it sure looks to me like gamma's obtuse, doesn't it? Just from the drawing, it looks like it's big, a little bit bigger. Okay. All right, so if we use law of sines, here we go. I got the sine of my angle given, which is 40. We have our side across from it is 2.6. And then we have to find the smallest guy. What's the smallest angle, beta or gamma? And how do you know? Julian? Yeah, beta's across from little 3 and gamma's across from 4. So beta has to be less than gamma. So that's the guy we want to find. Okay? So find beta. Beta is less than gamma. That's why I'm choosing beta. So sine of beta, and then across from beta we have is 3. So far, so good. We're going to go ahead and multiply by 3. So these guys cancel. So now I got 3 sine of 40 over 2.6, and that equals the sine of beta. Ooh. And then the last thing, go ahead and do what? Not subtract. How do I solve for beta? Do the inverse sine. And that's going to find that acute angle, which I'm looking for. Okay, so those guys cancel. So I get beta equals this guy in my calc. So go ahead and plug it in, plug it in. So I'll plug this guy in here so we can see it here. So I've got inverse sine, and then I've got, I'll use the alpha button here. So I go 3 sine of 40, and I'm going to divide by 2.6. So I got, when I use the rounded value 2.6, I got 47.9 degrees. Okay. Y'all good with that? Haynes?
So should we always use the rounded value?
I think for what we're using it for, just go ahead and use the rounded. That's fine. Use the 2.6 when you plug it in. Okay. Plus, we have some people that don't have the 83, so it makes it a little tougher to store that for those guys. So we're just going to use the rounded value with these. I'll have both answers. So I'll have, if somebody kept the 2.57-ish or whatever it was, they copied and pasted, I'll have both answers. Good question. Last question is, find gamma, right? And if you go 180 minus the given 40, and then minus what we just found, there's that obtuse 92.1 degrees with that rounded value. Okay. Questions with that? Questions. If I try to find gamma, I would not have found 89.1 because that's out of its range for inverse sine. Right? That's why we always find the smallest angle if you're using law of sines for a sassy triangle. Okay? Hopefully that makes sense. Questions? If you don't want to worry about that little rule with law of sines, then just stay with cosines. If you use law of cosines and go through and find that next angle, you'll have no issues. Because law of cosines will automatically find any obtuse angle. Okay? Because inverse cosine works in quadrants 1 and 2. There's no issues with that. All right, questions, y'all? Questions. All right, let's dive into number 2. This is different. This is a side triangle. If you're somebody that likes law of sines, then you have to follow this rule. So again, you can use law of sines later, meaning in your second step, if you find the largest angle first. So if you want to use law of sines later on, which a lot of people do, they just like it better. I like it better. But you have to be aware that inverse sine does not find the big guys. You'd have to do the supplement. I don't want to worry about that. I want to use inverse. I want to use my cosine, law of cosines, to answer the question as efficiently as possible. She's not here. So I'll say that again. Use law of cosines to find that big angle, the biggest guy. Because inverse cosine works in quadrants 1 and 2, where it's obtuse. So if I look, which one is the biggest angle? Who's the big guy? And how do you know? Alyssa. Gamma's the big guy. How do you know? Yeah, across from the biggest side is the biggest angle. So gamma is what we want to find first. Okay? So let's go ahead and find gamma using our law of cosines. I got c squared equals, so this is c. Across from beta is b. Across from alpha is a. If you want to put the sides there, you can. Using our formula, a squared plus b squared equals c squared. But then it's minus 2ab cosine of gamma. These two are at the bookends, right? They're across from each other. They're on the ends. Plug it in, plug it in. C is 7, so 7 squared. A is 3 squared. B is 5 squared. Minus 2 times 3 times 5. And the cosine of gamma. When we start doing some simplifying, 7 squared we know is 49. What's 3 squared? Shout it out. What's 3 squared? 9. What's 5 squared? 25 plus 9. That's 34. Minus 2 times 3 times 5 is how much? What do you guys get there? Jerdy? And then we have the cosine of gamma. You cannot combine these guys. They're different. One's a constant, one has a cosine attached to it. So then how do we solve something like this? What's the next thing we do? Somebody with a hand up. What do we do next? What do we got? Julian, what's next? Subtract 34. There we go. So that gives me 15 equals negative 30 cosine of gamma. Now we can divide this guy over. And if you want to reduce, you can. If you want to just leave it and throw it in the calculator, you can. I'd probably reduce it if I can, especially this one. Inverse cosine of both sides. And you could type that in, but if I remember right, adjacent is -1, opposite is √3. That'd be 60 across from that. So that'd be 120 in quadrant 2. So 120 degrees for gamma. Good stuff. Inverse sine would not find that guy. It would find 60, and then you'd have to subtract. Okay, that's why we found this guy first, just in case there's an obtuse, just in case this is an obtuse triangle, which it looks like it is. Well, now we can do law of cosines again, or you can do law of sines. Your choice. Since we found the big guy, we can do either one. What do you guys want to do? Law of sines? Okay, so we swap and do law of sines. It doesn't matter which one you find. I'm going to use the sine of 120 over c, which is 7. And then you can find alpha or beta. Again, it doesn't matter. Let's just go alphabetically and find alpha. And across from alpha is 3. Go ahead and multiply both sides by 3. So these guys cancel. And now I've got 3 sine of 120 over 7 equals the sine of alpha. And now my last step. go ahead and inverse sine both sides. And plug it in, plug it in. Go ahead and plug that in. We got inverse sine. I got 3 sine of 120 all over 7. And I got 21.8 degrees. You guys okay with that? Anybody not getting that? And then Jeremiah, how do I find the last angle? I'm going to go 180 minus 120 minus 21.8. And that will give me beta. So I got 38.2 degrees. Good stuff? Questions? Questions. All right. So it's your choice. A lot of you guys like law of sines. You have to follow the rules. If it's a sassy, right, do law of cosines and then find the smallest angle. And then subtract and I'll find the biggest one left. If it's a side, then use law of cosines to find the biggest angle just in case it's obtuse. And then law of sines will find acute angles pretty easily. Okay. Or just use law of cosines the whole time and you have no worries about those rules. Okay. All right. Last but not least, a little application of this guy. Ooh. So try this guy out. I've got a radio tower, 500 feet high, is located on the side of a hill with an inclination of horizontal of 5 degrees. How long should 2 guy wires be if they're to be connected to the top of the tower and secured 2 points 100 feet directly above and below the base of the tower? So there's a lot going on there. First off, what in the world is a guy wire? Is it a wire that's a guy? No. What's a guy wire? What are those for? Any ideas? Yeah, so there's towers, cell towers and stuff. You'll see these lines coming off of them. That's, on high winds, they could be swaying back and forth. So they put these tension wires down so it doesn't really move so much. It's just support, okay, so they don't fall over. All right, so that's what these guys are. We're trying to find this guy here. We're trying to find this guy here. All right, so they told us this angle is 85 degrees. So right there is my first triangle. Try to draw it to my best of my ability here. This guy's X. This guy's 85. This is a hundo. And this guy is 5 hundo. Well, if I look, that is a side angle side sassy triangle. So that means the only thing I can do right now is law of cosines. Okay? It doesn't matter what A, B, and C are. Your choice on how you want to set it up. I just remember my angle and side that I have are going to be the bookends, right? So 85 is the angle that I've got. So that means X is the bookend that's all by itself. So take a second, see if you can't set up law of sines, or excuse me, law of cosines, and solve that guy. Then we got to do this next one. This is a separate triangle. Which means you got to know this angle. Well, this is a straight line here. So we should know that angle. So take a second with your buddy, see if you can't find X and Y there. Those 2 guy wires. Those are non-ambiguous cases. It's only the 5, 6, 7. All right, if you guys take a look, these are the bookends, the angle and the side across from it. So we should have x squared and then equals the sum of the squares of the other two sides minus 2 times the product of those two sides, and then the cosine of 85. And then when you solve that, what'd you guys end up with? 501.3 chickens? Feet. We should get 501.3 feet. Any questions? Anybody not getting that value? So double check on what you're plugging in if you're not getting 501.3 feet. The other guy's just a little bit bigger. Again, my two bookends are y and 95. So y squared equals the sum of the other two sides squared. The squares of the sum of those guys. I got 2 times a hundo times 500. And then I have the cosine of 95. The reason why that's 95 is these are straight. That's a straight line. 85 and 95 makes 180. Those are supplementary. You should eventually get y to be what? 518.4 feet. Anybody not getting those values? Anybody not plugging those in right? Because I can come over and help you out. All right, ladies and gentlemen, that is it for today. If you're looking at the worksheet, I have some. There, I gave you a worksheet that's 24-ish questions. We don't need to do all those. Let's cut this down a little bit. 1, 5. I've got 7, 13, 15, 19, and 23 I want you to try. So again, give those a shot. That'll give you a few. What do we got? 1, 2, 3, 4, 5, 6, 7 of those to try. Okay, it can kind of get tedious here, but once you get the hang of it, it's pretty easy. Be very careful on those sassy triangles. If you're using lost signs on the second step, and find the smallest angle that's left. And you should have no issues. If you got a side-side-side triangle and you want to use lost signs for the second step, find the biggest angle first. And ladies and gentlemen, that's it for today. We'll see you later.